Okay, so this section is section 5.3, medians and altitudes. So we're going to look at some of those and what they do for triangles. So what are the altitudes? The altitude of a triangle is a perpendicular segment from the vertex of a triangle to the line containing the opposite side. So it's pretty much the height of the triangle, the altitude. So from the vertex, perpendicular, because that means it's the shortest distance between a point and a line. And so it's perpendicular, okay? And if it's like so, then it's on the inside. But if I have an obtuse triangle, then that altitude will land on the outside. So I would need to extend this side to get that perpendicular length. That's what they mean by a line containing the opposite side. So you might need to extend your sides to be able to draw in the altitude of some triangles. Okay? And then the next one here is the median. What is the median of a triangle? It is a segment that has the endpoints at a vertex and at the midpoint of the opposite side. Okay, so that's not an angle bisector. Okay, it does not bisect this angle. What this does is it goes from the vertex to the midpoint of the opposite side, and so those two pieces will be congruent because that's the midpoint. So what does this mean? How does this come together? And what do we need to know? Well, let's start with the medians. The medians, if I draw all three of them, will all have a point of concurrency. Okay, and that concurrency is called the centroid. So what is the centroid? The centroid is a point, okay, and its characteristics are it is 2/3 of this distance from the vertex. So this distance right here, from A to P, is 2/3 of the entire length of that median. Same thing from every one of these. This distance is 2/3 of the whole distance. This distance from C to P is the distance, 2/3 of the distance from the whole thing. Okay? And what's unique about that is the centroid is considered to be the balancing point of the triangle. If I took a triangle and I made it sturdy enough, and then I put a pin or a nail just pointing up like that, I could set the triangle right on top of that point at the centroid, and this triangle will be balanced. Okay, it's the balancing point. That's something interesting. Okay, so that's the centroid. The next one is the orthocenter, which is the point of concurrency for altitudes of the triangle. So if I draw all the altitudes of a triangle, they're going to intersect. I might need to extend the altitude out because the orthocenter could be outside the triangle, as you can see right here. It's the point of concurrency of the altitudes. If I have an obtuse triangle, the point of concurrency is going to be outside the triangle. An acute triangle is going to be inside. If I have a right triangle, it's going to be right there at the 90-degree angle, right there on that corner. So what is the orthocenter? It's basically the intersection, the point of concurrency of the altitudes. And one special note, we've talked about a lot of points of concurrencies and stuff like that. So one thing that's very interesting, in an equilateral triangle, all the points of concurrency are the same. So they all land at the exact same point. So the orthocenter, the centroid, the incenter, the circumcenter, they're all the exact same point in an equilateral triangle. That's just an interesting byproduct of that. So how can I use this knowledge to help me solve some problems? Well, let's go do one. So here's an example. You want to find the orthocenter of this triangle right here. So again, the orthocenter is a point of concurrency of the altitudes. So I need to find the altitudes of this. So to do so, we can see it's an obtuse triangle. To do that, we actually need to find the altitudes. Okay, you got to be able to draw them out. So one of the best ways to do that. Okay, so we have this one is already kind of there. It's kind of based off the drawing of the picture itself. So I know that I have an altitude right here. So the y-axis is indeed another altitude. So I can put a little 90-degree mark right there. So this is an altitude, right? So now I just need to extend the other ones. Because it's obtuse, it's going to land outside the triangle. So what I'm going to do is I'm going to extend this side as a dotted line. Excuse me, I thought you could see it. This extended as a dotted line. And then I'm going to extend this one as a dotted line. All I'm doing is extending the line, the sides, because I have to make an altitude to that dotted line. So what I have to do now is I have to get a perpendicular, okay, from here to here. I need a perpendicular. Right? I can do this a couple of different ways now that I have the extension. I can do the construction technique where I use the compass and I do a perpendicular from a point to a line. And that's where you take this thing, right? You go beyond the line and you make 2 marks. Okay, make 2 marks. So there and there. And then from here, you go out again and you make your crosshairs out here. From there, and then the other one, I think it was here, like so. And then I can connect it from here to there. Okay, so that's one way of doing it. I think I missed my mark out here. So my lines aren't matching up. But anyway, the other way is I can use the idea of slopes. Okay, the construction is pretty straightforward. You can do that one if you wish. I missed it over here, so I'm going to show you the slope approach for this particular example. So what I want to do is I know that whatever line I draw from here, it has to be perpendicular to this side right here. So I do know that the slopes of perpendicular lines are the negative reciprocals of each other. So I'm going to find the slope of this. This, by the way, is labeled A, and this is B, and this is C. So we have some reference here. So I'm going to find the slope of AB. Okay? Well, I can just do rise over run. It's a negative slope. I'm going to go down 1, 2, 3, and then over 1, 2, 3, 4. So I know that I have a slope of a negative 3/4. I can do the same thing and find the slope of this one. Since they're meeting up at 0, 0, it's just basically going to be y over x, so it'll be 3/6. So the slope of AC is going to be 3/6 or 1/2. So those are done. Now, how does that help me? Okay, so what that means is I'm going to do a perpendicular. Let's do this. Let's go to C first. I'm going to do a perpendicular to this line right here. Okay, and it has to go to that point. So all I have to do is find the negative reciprocal of this. So what we want to do is then from point C, we're going to take a slope that is the negative reciprocal of this, which in this case would be a positive 4/3. So from here, I'm going to do a positive 4/3. So I'm going to go down 4 and then negative direction 3. So I'm going to go down 1, 2, 3, 4, and then 1, 2, 3. And so I put a dot here. And then if I connect those 2 dots, it will be perpendicular. Line everything up. And so if I draw this out, and I'll do it a little bit like it's a dotted line also. A little bit darker so you can see it. Then I know that that is a 90-degree angle right there, and that is my altitude. Okay, I can repeat the same thing from this other one right here, and we want to draw the perpendicular to this thing. So we know the slope of this line is 1/2, so the negative reciprocal. So from A, I'm going to go a slope that is a negative 2. Okay, So that means I'm going to go from here, I'm going to go down 2 and over 1. Okay, down 2 and over 1. If I line everything up, it will be perpendicular there, and we can see that they intersect right there. Remember, there was an altitude right here on the y-axis, so all three of them intersect at the point right there. And so that is my orthocenter. We can call that point D. So my orthocenter is the point D, and that is at 0, -5. So that's the slope approach. Again, you could have done the construction approach also. Here's another one for the centroid. How do I locate the centroid in a triangle? Okay, so the first thing you want to do is, and we're in a grid situation, so we're going to use the coordinate system to help us find the coordinates of that point. And so I gave you a little kind of guidelines to follow here to help you get it. And so the first thing we want to do is we want to find the midpoint of two sides. So any two sides will work. I'm just going to pick the midpoint of this side and the midpoint of that side. So what is the midpoint, okay, of AC? Add the x's, divide by 2, add the y's, divide by 2, and I get the point 1, 3. And if I look closely here, you can see, yep, it goes through 1, 3, right there. That's the midpoint. What's the midpoint of the other one? Of BC. Add the x's, divide by 2, add the y's, divide by 2. I get 6 over 2, which is a 3, and 1, so 3, 1. And sure enough, there it is. Okay, that is part A. We found the midpoint. Now we want to find the equation of the two medians that go through the vertex and the opposite side. So that means I need to find the equation of this median and the equation of this median. Okay, so we want to find that equation. And so what I need to do then is let's take the equation of this one over here. I'm going to go the equation from B. What is my equation from B? Actually, we got to find the slope first. To find the equation, we need a slope and a point. We'll use this point, but I need to find that slope. We can find it fairly quickly. It's going to go from here to here. And so I know the value of this point is 1, 3. I know the value of this point is 3, 1. So what is my slope from B? What is the slope from here? I'm going to go up 1 and back 3. So that is a negative 1/3. What is my slope from A? Well, from here I'm going to go what? Down 1, 2, 3, 4, 5, and over 1, 2, 3. So that is a negative 5/3. So now I found my slope. So to write the equations, okay, then I need to use the point slope formula. From B, we use that point right there. It's going to be y minus 2, negative 1/3, x minus 4. And cleaning all this up and making it look pretty, y is going to equal a negative 1/3 x plus 10 over 3, and you can do the math and check that out. To do the other one over here, we're going to use the A point, so y minus 6, negative 5/3 x minus 0. And cleaning that up, we're going to get y equals a negative 5/3 x plus 6. That's part B. Now, part C is to solve this system. So the system is y equals a negative 1/3 x plus 10/3. Y equals a negative 5/3 x plus 6. And I want to solve that system. I'm going to use substitution because they're both already solved for y. And what I end up with is a negative 5/3 x plus 6 equals a negative 1/3 x plus 10/3. I'm going to start off by getting rid of all my fractions. I'm going to multiply everything by 3. Gives me a negative 5x plus 18 equals a negative x plus 10. Moving everything around, solving for x, I'll save that. You guys can check it all out. I'll get x equals 2. Okay, so if x equals 2, then I can take that, plug it back into an original equation, and find the y value. So I'm going to plug it into the top one. So y equals a negative 1/3 times 2 plus 10/3. And so I can see that y is going to become 8/3. So my centroid is the point 2 8/3. Now let's see if we're kind of close. This right here is 2 2/3. 2 2/3, so about half, 2/3 of the way up. Yeah. And so it's at 2, and it's at 2 2/3. Sure enough, that is my answer. There's my centroid. Okay. So these are some things that you'll be asked to do.